Hey, welcome back. This is Shoptalk for June 2017, and I just want to go over a few things that have changed in my shop. This video will not contain any actual machining, so this is just talking and showing new stuff. So, biggest change that some of you might have seen on Facebook or on my Instagram account is the fact that I bought a CNC router. That's right. 2 years ago I sold my CNC milling machine and I bought a manual milling machine, and last weekend I bought a CNC router and I set it up, and it's working and it's waiting for actual work. Yeah, I said that I prefer a manual milling machine in my shop, and that's still right for as a general purpose milling machine. I really prefer a manual milling machine, but a CNC router is great for prototyping, 3D machining, and everything that's non-ferrous metal or plastic, or even wood if I want to. And I run a CNC router at work all day long, and I think I'm rather experienced with those machines and their capabilities, and also with doing CAD and CAM work and 3D machining and prototyping complicated parts. Unfortunately, I cannot show the parts I do at work because it's R&D work, but I can show the techniques that I use at work with my own parts now on the CNC router at my own shop. So enough talking for now. Let's go over and look at the CNC router. Obviously my shop is rather small and it's full. There is no space for any additional machinery in here, so I took the router and I placed it in the storage room next door, and I set up a small CNC area in there. So let's go over there and have a look. So that's the machine I bought. It's an Easel Mini Flat 40. That means it has a travel of 400 millimeter by 295 by 150 millimeters, and it can pass workpieces up to 200 millimeter height below the gantry. It's a moving gantry machine. That means this whole part here moves back and forth while the table is stationary. The advantage of this design is that the space requirement is quite small, opposed to a machine where the table is moving. Then you have to have the length of the table plus its travel, which can get quite big in a hurry. I bought a Cress FME P 1050 router motor, which takes standard ER16 collets, which is quite nice, and the taper in these router motors is machined quite precise. Runout in taper is 2 to 3 thousandths of a millimeter, and when I chuck up a gauge pin in a good collet, I get a runout of about 1/100th of a millimeter in a distance of 40 to 50 millimeters to the collet nose, which is plenty good for a router motor. It runs from 5,000 to 25,000 RPM, but above 15,000 RPM your ears start to bleed in a hurry. So 5 to 15 is a very good range for this motor. The Easel mechanic, the XYZ mechanic, is all built in Germany. Even the ball screws, the ball nuts, and the aluminum profiles, the extruded aluminum profiles, everything was made in Germany on these machines. Unfortunately, the mini flat series is discontinued. This was their low price range of machines, and seems like it was too low price. I think this machine was back then, when it came out, about 1700 euros. Now the cheapest easel machine is something like 2,500 euros. The machine runs with steppers. XYC all have 2.5 amp stepper, two-phase steppers, and 5mm pitched ball screws. The ball screws from easel are interesting because they use a single nut, but they are adjustable. You can adjust them to be pretty much free of backlash. Not perfectly, but pretty much. Cable management on the machine is really very nice. There is a cable chain back there that goes up to the gantry, and a cable chain up here that goes to the C-axis. They even thought so far to put in a 230 volt line that goes up here to this junction box, and where the router or your milling machine spindle can hook up to, your high frequency spindle or whatever you hook up to the machine. When you buy the machine, it comes without the bracket and the router motor. You can hook up whatever you want, a laser, a plasma cutter, a sheep, a router motor, a whatever, a 3D printer head maybe, whatever. But I wanted a router, obviously. So yeah, that's the basics of the machine. As I said, the machines are not built anymore. This is new old stock. I bought it on the original pallet with the original wrapping around it for a pretty good price. Okay, we're doing a very professional screen capture here with the camera pointed at the monitor. And the software I'm running is LinuxCNC, because I'm already used to it, and I get iCancer from Mach 3. Start the software. Hit go, and now the machine is enabled. First thing, of course, is to move the machine to its reference position, and all the axes of the machine have reference switches built in, so it was just a matter of hooking them up to the controller. We hit reference in LinuxCNC, and the machine searches for the reference switches. Now the machine knows where its machine 0 is. And the soft limits are also activated, so I cannot over travel the axis. I set the machine to a rapid move of 4.5 meters per minute. See, when a few millimeters before it hits the hard stop of the axis, the soft limit just stops the movement of the axis. Same in Y direction, and of course C direction. With the soft limit in the C- direction, you have to be careful, because most of the time the tool will hit the table before soft limit is engaged. But that's obvious. I didn't hook up the spindle to the CNC controller yet, so I'm turning it on and off by hand. and it's reasonably loud. This is 5,000 RPM. This is 10,000 RPM. That's about 50. This is 25,000 RPM. This is really annoying loud. I would have to raise my voice quite a bit so you can hear me. Above 15,000 RPM, this is a clear case for ear protection if you want to work the same room as this motor. What I'm going to add is a enclosure because a CNC router with its high RPM spindle is notorious to throw chips all over the place. So that's one thing that's coming for sure. I'm just going to build it out of aluminum extrusion and some 6mm polycarbonate, which can stand up impact from a breaking tool or a workpiece that has gotten loose. So back at the software, the LinuxCNC with the Axis GUI, which is what you see here, is very basic. You have manual mode where you can jog the axis around with the cursor keys and page up, page down for C movement. You can switch to incremental move, 1/100ths of a millimeter per step, 0.5, 0.05 and 0.1 per step. You can set your coordinate system to 0 or any value that you want, like 20, or you can also do basic math in there, like 20 divided by 10, which can be very helpful. You could turn on the spindle here if you hook it up, and you can also turn on and off a relay for coolant or stuff like that. Both of this is not hooked up yet. You can open a program like this. This is oh, I did some experimenting with a trochoidal toolpath in Fusion 360, adaptive clearing for a slot, which worked quite well. And yeah, you get a 3D preview of your toolpath. You can zoom around, you can change to a top-down view so you can see the actual toolpath, and you can run it from here. And we can run this program now, just to see how the machine behaves. We zero our axis in a safe position where we do not crash into something. And now if we hit run, the machine will do its thing. One thing is the Fusion 360 LinuxCNC post-processor puts out a move that I don't like very much. In the beginning of the program it moves to G53 set 0. That means it moves the Z-axis all the way up to its machine, to the reference point, and then it goes down to do the actual machining. I don't like that. I'll have to, I will see if I can edit that out of the post-processor. Don't like that. And there we go. I will not turn on the spindle. This is just to see the machine in action. That's of course a trochoidal toolpath, which, yeah, which can get quite annoying if you watch the machine. Cleanup, pass. And done. Okay, let's show some actual machining. I have a piece of plastic, a 6mm bullnose end mill with a 0.5mm radius on its edge, and the spindle, and I made a small program in Fusion that will create a dome shape on top of this material. So let's see what we end up with. I'm not very fluent with Fusion. I'm used to work with Pro Engineer and Creo. Yeah, that's our dome shape. The toolpaths Fusion put out, or should I say the toolpath I created and Fusion put out, were not ideal. I finished with a spiral motion from top down, which is for such a shape not perfect. A sane person would move spiral from bottom up. So you're cutting with the side cutting flutes of the end mill, not with the front flutes. And I didn't find a way to specify a surface roughness. I only found a way, the step over or the pitch of the spiral toolpaths. I prefer to have a surface roughness setting. I hope that Fusion has something like that. Otherwise, finishing can take quite a while because you have to set a very small increment for your finishing. With a surface roughness, you can set a very large step over and specify, for example, 5,000 of a millimeter surface roughness. And when it needs it, it will create a denser toolpath by its own. Didn't see that in Fusion yet, but I think it has this option. At least I hope. Apart from that, worked out quite well. In the beginning I had the speed of the router too slow and I was taking too heavy of a chip, so I increased the speed to 12,000 RPM, which is what I used in Fusion to program. There we go. That's the dome-shaped part. Completely useless. I didn't do anything to check the geometry of the machine yet. I didn't measure the squareness of the spindle to the table, squareness of the axis to each other, and so on and so on. I will do that in the future, and I think that's enough for a quick look over the CNC router. Expect a whole lot of boring CNC machining videos in the future. So let's go back in my main shop to see what else changed. Oh, before we go back, a CNC machine, CNC router, of course, makes hell of a mess. And I have a shop vac, a Festool CTL Mini over in my main shop, and it's set up with a cyclone. So it's built-in fixed. It's a hassle to move it over. So I broke down and bought another shop vac for my CNC shop, a Bosch GAS 20, which can be used without filter bags, and it has self-cleaning function for the filter. Where it reverses the airflow and knocks off the dirt from the filter, so should work out. Speaking of dust collection, I use this Festool CTL Mini in my shop as the main vacuum cleaner for everything, and the dust bags for this guy have gotten pretty expensive over time, so I bought one of these El Cheapo early cheap cyclones, It's a rip-off of the Oneidos Dust Deputy, but this is about a fifth of the cost. And I bought the steel bucket and tied it all together with some with an additional hose, and it's perfect. It works so well. It's incredible. I use it also I use it to suck up everything from grinding dust. This is from grinding bench stones, precision ground bench stones, to pretty substantial chips. Everything goes in there. Oily chips, wet chips, dust, wood chips, drill chips, everything. Doesn't matter. And when the bucket gets full, I just dump it in a trash bag. I do that outside, so I do not dust up the shop with the crap inside this guy. And the dust bag and the vacuum cleaner itself lasts really very long that way. I filled the bucket here up 3 times now, completely full to the brim, and I still have the first dust bag in the vacuum cleaner. So this will save me so much money over the run of time. So can only recommend this, or something like this. A lot of people build these cyclone separators themselves, but considering the price, I didn't want to mess around with it. Like using a traffic cone and try to glue stuff to it. I just, yeah, this is a bought thing and it works. Last major change in my shop is my bandsaw. I used to have one of those 4x6 Chinese, Taiwanese, whatever bandsaws, and it was really a very good unit. It's very serviceable. It has cut so much material for me. And I still have the saw, but as you can see, I modified it. It's now a vertical bandsaw. I took it off its stand and I mounted it on a very tall, narrow table, so I have now a vertical bandsaw that's the right height for me. And I did this about 2 months ago, and I'm super happy with it. It's so useful. I'm used to a vertical bandsaw at work, and it's a very useful machine, not only to process raw stock material down to length, but also for material removal before you go to the milling machine. Everything that you can do on a bandsaw is faster than doing it on a milling machine. If you can cut out a huge chunk of material, that's faster than try to rough it down with an old end mill. And you are left with a piece of material that you can use. Just like with a rotor broach or an annual or cutter, you will end up with a piece of material that you can use, not only chips, which are quite useless. So I took the bandsaw, mounted it on its stand, and I also removed the original belt drive and the single phase motor and replaced it with a proper SCV geared motor. SCV is, by the way, also a German-made motor, and removed the original worm gearbox, which was really worn down, and mounted it directly to the saw, and the lower wheel of the bandsaw sits on the shaft of this gearbox. This is of course, industrial equipment, so this gearbox will outlive me. I also bought a Omron VFD, so I have variable speed, which is quite nice on the bandsaw. Goes from pretty much 0 to quite fast. The speed range I have here ranges from 0 to I think 100 and something, 120 meters per minute cutting speed or surface speed on the saw blade, which is very good range for steel, aluminum, and I also can cut wood with it quite good. For wood you would prefer a quite high speed, like 1000 surface meters, but this works also. I have a very coarse 6 to 8 teeth blade on the saw, and this is this is a ripper. I cut this piece of cast iron. This is 400 millimeter long. This is going to be this is the waste piece. The other piece is going to be a straight edge. I cut this on the bandsaw like this, quite fast. I have some stock footage that I might show you. Mounting the bandsaw was quite easy. I welded 2 pieces of 30 by 30 millimeter square tubing to the top of the table. One here and one is on the other side of the frame. And I just bolt through this pipe into the frame of the saw. I drilled and tapped threads into the frame. That's very sturdy. Speaking of sturdy, of course, having a small shop, the footprint of the saw is now very small. Normally the 4x6 bandsaw needs quite a lot of space footprint wise. This now has 40 by 30 centimeters footprint and houses a lot of my stock raw material, which is quite nice because it gives this saw some mass and it sits very good on its feet. Okay, these are the major changes in my shop. Of course, the CNC router is the biggest change, and I have to put some work into the machine to make it an everyday use machine, because without an enclosure it's really a mess. And also I'm going to add a dust collection to the machine itself. But apart from that, I'm already very happy with it. I need to change the table the machine sits on has wheels, and that's not good. I'm going to change those for some rigid feet. Apart from that, yeah, everything's hunky-dory. So, thank you all for watching. See you next time.